Hey everyone, we're looking at the lesson 26 through 29 review here. So to begin, we're going to be looking at the oxidation number of each element. So you have N2O3. With this, if you need to go back and look at the rules, you can do so. But you'll look and see that oxygen is -2. So -2 times 3 makes this -6. And so oxygen is -2, which is what all of them say. To balance out -6, you have to get this to +6, which will require each nitrogen to be +3. So nitrogen has to be +3. So here's your answer. Right here, we need to end up, we know oxygen is -2. There's 3 of them, so they make -6. However, there needs to be -2 left over. So the positives coming from the carbon can only be +4. So carbon is +4, oxygen is -2. Wait, did we already do this one? No, never mind. Mg3N2. For that one, we know that Mg is +2 because it's in group 2. I have both of these things opened, so if you look, it's in group 2. And so +2 times 3 makes it +6. And then on nitrogen, it'll be -3 times 2, which makes it -6. So +2 and -3. So +2, -3. On this one, we need to have a -1 left over. Oxygen is -2, and there's 4 of them, so that makes a total of -8. Hydrogen is +1, and there's only 1 of them. So now our total is at -7 overall, combining the hydrogen with the oxygens. We have -7. We need to have -1 left over. So sulfur must be good for +6. Okay, now with these, it's a little different what I have you do. I want you for these to name these and type the name in. I'm having you do it this way so you will actually go through and think about all of the rules. This is much harder than what I've been doing where I tell you if they're ionic and then I give you a list of names to match to all the different formulas. This is harder to just come up with the name on your own by scratch like this. So what I'll do is as I go through these, I'll type in the correct names. So you'll see what I'm typing so you can make sure to have the correct answer for full credit. But I want you to have tried this before you see me go through it. So go through these, try your best. It'll make it so when I go over stuff, if you're correcting your own mistakes, you'll just learn it a lot better. So with this, it's iodine and oxygen. What we need to ask ourselves, let's look at where those things are. Iodine and oxygen are both over here. They're both negatives, so this makes it covalent. So when it's covalent, it uses the Greek prefixes. So this will be diiodine pentaoxide. Notice I'm not using caps. Make sure that you don't use caps when you're doing this as well, so that way your answer ends up being right. So there's our answer for that. Let's go to the next one, Mg and then N. But look at where they're at. Magnesium is on the left, N is on the right. They're on opposite sides of the periodic table. You have a positive and you have a negative. So this is ionic. Remember, for ionic, we don't use Greek prefixes. So when we do Mg3N2, we just say magnesium. I'm not doing any caps. So let me fix that. Magnesium nitride. Magnesium nitride. All right. Now we have chlorine and oxygen. We look at them in the periodic table. Oxygen right here, chlorine right here. This is going to be covalent because they're both on the right side. So for covalent, we do need to use the Greek prefixes. So it'll be dichlorine. 7 is heptaoxide, and with an "ide" always. Number 8, calcium and oxygen. Let's look at where they are at. Calcium on the left, oxygen on the right. This is covalent. I'm sorry, this is ionic. So we don't need to say mono, di, tri, none of that. So this one is going to be just calcium oxide. Okay, now we get right here. Look at what we have. We have one of these polyatomics, and it's PO4. So we'll look on this chart, and you can use this chart during the test. PO4, which is phosphate, and you'll see it has a -3 charge, which is why, so it's a -3, and it's with a Ba, which is barium, and you'll notice barium is a +2. That's why there needs to be 3 bariums to counter out 2 of the phosphates. But let's go ahead and name it, and this thing is going to be barium phosphate, just like that. Let me make this thing worth a point. Okay, let's go to the next one. we have Ca, and then this whole C2H3O2. C2H3O2, you'll see it right here as acetate. Ca is calcium. I'm not even going to the periodic table. I'm hoping you're starting to get some of these memorized by now. Make it worth a point. And there we go for that. Next up, CO and S2. Now, look at it doesn't tell you to use it. I'll make sure that I tell you whenever it's stock system, but you'll notice cobalt is right here in the middle of the transition metals, the ones where I haven't given you set charges for those. That's because in order to figure out the charge of cobalt, you need to look at what it's bonded to, and it's bonded to 2 sulfurs. Each sulfur is -2. So for cobalt to be bonded to 2 sulfurs means that cobalt must be producing a negative or a positive 4 charge. So our answer will be cobalt IV, which is the Roman numeral for 4. And then always end in I. Cobalt 2 or cobalt 4 sulfide. Okay, now we have a lead and a CrO4. Let's look at what CrO4 is. It's chromate and it has a -2. So that must mean that lead just has a positive 2 charge. So it's going to be lead 2, chromate. Oh, also, just so you know, the way I'm doing this so that you can enter the right answer, I'm just turning on the capital. I'm just doing capital I for this. So this was, when I did this one over here, it was capital IV. And make sure you do in parentheses and then start parentheses, end them. Okay, right here, we're going to have, have I been making these worth a point? Yeah, I have. Okay, so right here, we're doing hydrates. Remember the rule for hydrates? We're just going to name it like we've been doing. So sodium is Na. SO4, let's look at that. SO4 is sulfate. Sodium sulfate. And then 10 is deca, and since it's the water, you say decahydrate. Okay, number 14, we have iron, Fe, but remember iron is right here in the middle where there's no charge. So we're going to use stock system. So iron is bonded to another sulfate, and look at sulfate has a -2 charge. So it's going to be iron with a charge of 2, sulfate, hepta for 7, hydrate. Okay, number 15, HCl. Now we're doing acids. It's a binary acid, so you need to start with hydro. And so we have hydrochlorine, but we end it with ic acid. Okay, now we have Te. Let's look at Te right here. If I zoom in, tellurium. So we'll say telluric. So this will be hydrotelluric acid. Why do I start with hydro? Because it's a binary, meaning it's coming from the periodic table. Okay, now we have ASO4. So ASO4, let's go right here. And let's look at ASO4, and that's arsenate. And you'll notice that you have to have 3 hydrogens to balance it out. So since it's an 8, you change 8 into ic acid. So this would be arsenic acid. All right, and then NO2 is nitrite, so just change it to nitrous acid. All right, so that's how we do these. Now remember, you're not going to have to type them out, mainly because on a test, I would rather actually make you type them out. But on the test, there's just so many little typos you could have, or caps could be off. It's just, there's too many things that could go wrong to mess up the answer. So it will be multiple choice, but it'll ask you to name a compound, and then it'll have a multiple choice of 4. It won't be like the other ones where I had like 5 compounds, 5 names, and you match them. That's just too easy. So make sure that you understand it on the level where you can write the names like this, and then you should be ready for the test that you'll be taking next class. All right, as always, email me if you have any questions or concerns.